Okay, guys and girls, so today we're going to review the second half of this unit, which was inverse trig functions and composition of trig functions. So a few things that you should have handy here, okay, are your unit circle, right? And then make sure that you write down your restrictions on your inverses as well, because that'll come in handy when you're finding any inverse trig expressions. And then finally, make sure that you are ready to flip back page 22. You might see some of these guys for the composition of functions. And those are when we have the same, well, we have a trig function and its inverse and the little kind of rules that we can apply for those scenarios. So once you have all that, then you follow along. I'm just going to do let's say maybe 5 or 6 examples here, and then we'll go ahead and have you guys complete the rest as practice. So we're looking at 47 through 66 here, and let's start off easy with 47. Right? So here we're trying to find the inverse sine of the square root of 2 over 2. So essentially all that's asking is where on our unit circle is sine equal to the square root of 2 over 2. And I see 2 spots here. If we look at pi over 4, our sine is square root of 2 over 2. And if we look at 3 pi over 4, our sine is also square root of 2 over 2. Okay, but we have to remember that we have restrictions on inverse functions for trig. So we have to check out this guy. It looks like sine can only be from negative pi over 2 to positive pi over 2. So that's going to be that pi over 4 that is inside our restrictions. Okay. Remember with tangent, we have to find that ourselves. So here we're looking for where is arc tangent equal to negative square root of 3. So go back to your unit circle, and we're looking for where is tangent equal to negative square root of 3. So remember, tangent is sine over cosine. For example, if I'm looking at pi over 3, root 3 over 1 is going to be my tangent, right? But we're looking for negative root 3, so that looks like it's going to be 2 pi over 3. If we do sine over cosine there, we get negative square root of 3. And also over here in our fourth quadrant, I think 5 pi over 3. So we have 2 pi over 3 and 5 pi over 3 as our answers here. And so the thing we have to take into account once again is our restrictions. If we take a look at these guys, it looks like tangent is restricted to negative pi over 2 to positive pi over 2 when we're dealing with the inverse. So if we're checking out the 2 options we had, which was 2 pi over 3 and 5 pi over 3, 5 pi over 3 is the guy who works for us. What we actually want to make sure we do, though, in this scenario, remember our restriction was from negative pi over 2 to pi over 2. So what that implies is that we want to actually rewrite any of these angles in the fourth quadrant as just a negative angle. It's really easy to do that. 5 pi over 3 is actually just negative pi over 3. Right, so that would be our final answer there. And just a quick mini lesson on all these guys, like 7 pi over 4 is just negative pi over 4. 11 pi over 6 is the same as negative pi over 6. So those guys are really easy to remember because you just keep the denominator. Right? Okay, so now let's check out one of these guys where we have, let's check out 52. We have sine of the arc sine of 55 over 4. So this guy's a composition, right? But what you'll notice is we have sine and its inverse in the same expression. So this is one of those guys where you'd actually flip back to page 22 and look for that same scenario in our little chart here. So here we have sine, and then the inverse sine of x is equal to x. But for this to be true, we have to be between negative 1 and 1. So let's take a look at this guy. Are we between negative 1 and 1 with 5 over 4? Yeah, it doesn't look like it, right? So just like that, we could just say it does not exist. Otherwise, if it was between negative 1 and 1, we could just say it was equal to that value. Okay, that's what all these properties are telling us right there. Okay. So now let's check out one where we are going to go ahead and have some different trig functions in there. So let's check out something like number 60 here. So I have the cosine of the tangent, the inverse tangent of 1. So the cosine of the inverse tangent of 1. So remember, with these guys, you're going to work from the inside out. So the first thing we want to do is figure out what is the inverse tangent of 1. So we got to do a little work here. Right? First, we got to go to our unit circle and decide where is tangent equal to 1. Right? I am seeing two scenarios here. Pi over 4, right? Sine over cosine is just 1. And then I'm also seeing 5 pi over 4. Negative square root of 2 over negative square root of 2 is equal to 1. So those are my two scenarios, but remember, with inverse we have restrictions. Tangent is restricted to the fourth and the first quadrant, from negative pi over 2 to pi over 2. So our answer must be that pi over 4. So we're able to rewrite this guy, and we just said the inverse tangent of 1 is actually pi over 4. And now all we have to do is find the cosine of pi over 4. So go back to your unit circle. Cosine of pi over 4, you go to pi over 4. The cosine is the square root of 2 over 2. And we have our solution there. Okay, so remember to keep an eye on your restrictions whenever you're dealing with any of your inverse functions, which, remember, that's either the little -1 exponent or if you see arc in front of it. Those both mean the same thing there. And then the last scenario we have is when we have a value that's not on our unit circle. So for example, if we have the sine of the arctangent of -24 over 7, right, this is a scenario where we have to do the same thing we did on our lesson on Monday, which first was decide which quadrant this angle must lie in. Remember, this represents some angle. We just don't know what it is yet, right? But we do know its tangent is -24 over 7. So let's go ahead, and if tangent's negative, it's not going to be in the first or the third quadrant, right? So then, to narrow it down even more, we're going to go ahead and think about our restrictions. We have an arctangent right there, which is an inverse function, and that means it can only go from negative pi over 2 to pi over 2, which is quadrants 4 and quadrants 1. So it's got to be this guy right here. Okay, so quadrant 4 is where we're going to be, and that'll help us decide whether our final answer is going to be positive or negative. Right? The next thing we can do is we can actually draw a right triangle to represent this angle, theta, right? We know the opposite and the adjacent are 24 and 7, right? All we have to do to figure out the hypotenuse there is 7 squared plus 24 squared equals c squared. And I think when we do all our work there, we get something like 25 for our c value. Right? And now we still don't know what that angle is, but we know all the sides that correspond with it. So what we can do is, if we're looking for the sine of this angle, which, remember, that's just theta, represents theta, right? We can just go ahead and do SOHCAHTOA, opposite over hypotenuse, right? So 24 over 25. And the last thing to check out is just make sure that your sign is correct. In this case, we're in quadrant 4, right? The only positive there is cosine. So we got to go ahead and make sure, because we just found sine, that we put a negative out in front. Right? So what I want you guys to do is do the remainder of these guys. A lot of these should be pretty quick. Right? Remember, you want to have 3 things available to you: the unit circle, a little cheat sheet on your restrictions for inverses, and then also page 22. Right? Have fun, and I will see you guys tomorrow.